Good morning, everybody.
Yes, you start.
Okay, thank you. Today, we have one very esteemed speaker with us, Dr. Dhanpal Chavan. Sir has completed his MSc with merit with SET and NET. Sir has completed his MPhil at SIT-MU University, Nanded, and he also has done PhD from the very same university. Dr. Chavan has published more than 20 national and international research papers in peer-reviewed reputed journals. Sir has completed one minor research project, and Sir has published 3 books on the microbiology subject. Today, I am very happy that in our PhD webinar series, we are having our 13th consecutive speaker, Dr. Chavan. Before I ask Dr. Chavan to start his lecture, I would like to request Dr. Deshmukh sir to speak few words.
Thank you, Dr. Jess,
Thank you,
for your continuous efforts in arranging a lecture of fresh PhD student. Fresh PhD students are always inspiring young generation. And today you can see more than 35 participants have joined. And even on the YouTube, many will watch the lecture. So I am very happy we are creating microbiologist society. Is creating good environment in India, and we are serving India via microbiology subject. So I request all participants visit our website microbiosociety.com. So .com is the .com is the website of Microbiology Society, and we'll work together and we'll try to elevate the standard of microbiology in India. Thank you, Jay sir.
Thank you, sir. Sir, I would request you to make me co-host so I can let in the people.
I will make you host.
Thank you. Now I would like to request our esteemed speaker, Dr. Dhanpal Chavan, who is working as assistant professor, ACH College, Gangakher, Maharashtra, to start his lecture. And during this time, everyone, I request you to please use chat box if you have any questions. Thank you, sir. You may start.
Thank you, everyone. I'm audible to all of you, please.
Yes, sir. Loud and clear.
Okay, sir. And screen is visible to all of you?
Yes, sir.
Okay. First of all, I would like to thank Professor Dr. A.M. Deshmukh, sir, who provide us this platform to present our work to the community of our Indian Microbiology Society. So I am happy here to present my PhD work. So as organizer has given me 30 minutes. Within that 30 minutes, I will try to wind up the work of my PhD. So I very much thank you to Professor and our guide, Dr. A.M. Deshmukh, sir, who boost us to be ahead in many activities. So with that, I start my research topic. So I only put some facts regarding the microalgae. So my title was Studies on Role of Microalgae as a Source of Biofuels. So this thesis under this title was submitted to SRT-MU University, and the referee has given very good comments regarding this work as well as little bit suggestions. So I should improvise those suggestions while delivering my this lecture. So microalgae, we start with the microalgae. So microalgae, either they may be prokaryotic or eukaryotic in nature. So algal biomass is abundantly found on our earth, and this is the key backbone of energy on our planet. So as we discuss about this bioenergy, means biofuels, so other generation fuels, so fossil fuels still will be exhaust in near future, as well as the renewable bioenergy source is demanding as the population of world is continuously increasing. That definitely make impact on the global energy demand. So
Excuse me, Dhanpal sir.
yes, sir.
Go to presentation mode.
Yes, sir. With that,
Please continue.
so algae are prokaryotic and eukaryotic in nature, and algae they are unicellular. Those algae are unicellular. Those whom we call as unicellular algae or microalgae. Now both prokaryotic and eukaryotic algae are considered as a microalgae. So algae contain about 20 to 40% fatty acids in their cell. Algae also contain large amount of cellulose. Because of this, algae can be utilized for the production of future biofuels. From algae, biofuel like ethanol, biodiesel can be obtained. The cellulosic biomass subject to simultaneous saccharification and fermentation to produce the bioethanol. And the fatty acids from algae are used to produce biofuel using a transesterification reaction. So where is the research gap? So research gap is so far the algal biofuel is not commercialized for the production of bioethanol. Lipid from algae is still not commercialized. Algae biodiesel is in nutshell. In addition to this, the algal growth rate is very slow under natural conditions. In experimental condition, it was good. So it is the challenge to grow the algae in natural environment with growth, high growth rate. Laboratory studies for biofuel production is reported by many scientists across the globe. So what was the objective when the studies was carried out? So the objective was to isolate the potential algae which able to produce more fatty acids. So those algae are screened out, and the algal lipid was isolated to transform them into biodiesel. Then the residual cellulosic material into bioethanol simultaneously by saccharification and fermentation. And detection of these oils and biofuel with standard method like GCMS, then IR and NMR, these are the study. So what was the actually experimental work? Algae was collected from a local area, typically at the bank of Godavari River, and microalgae are isolated by using BZ11 media, and the sample was collected in the year 2015. Microalgae sample was collected in sterile container and kept tightly during transport to the laboratory. So pure culture was isolated, and this isolated culture was maintained on the BZ11 media, and enrichment was carried out with 25 degrees centigrade under 1 to 2 lux light irradiated for 60 to 8 hours light and dark cycle, and that was maintained up to 8 days. Pure culture were isolated on BZ agar medium was preserved. So then algae was allowed to grow for the production of biomass, and biomass was obtained and the biomass was processed. So microalgae was grown in 100 ml conical flask for the period of 3 weeks at 35 degree in light and dark cycle, as I said. And this after the incubation, biomass was collected. It was dried and filtered throughout the sieve, and the contents of algal biomass for the presence of cellulose and sugar was checked, and then saccharification of algal biomass was carried out. So here simultaneously two ways are worked out. First, the lipid was extracted, and that extracted lipid was transesterified into ethanol. The residual material after the extraction of oil was sacrificed So saccharification of algal biomass is carried out. Element mass was taken along with distilled water from 5:1 proportion. Hello, is I audible, sir? Hello?
Yes, sir. There is a little breakdown in your voice, but I think you are clear now. Please proceed. Hello, Chavan sir.
Now I am audible to you.
Yes, sir. You are audible. Please continue.
Oh, okay. And the
And sir, you can switch to
extract was hello.
you can switch to presentation mode, sir. On the right of your screen, bottom right, there is an option. So your slides would be better visible.
Presentation mode. What can you say, sir? Hello. Hello. Hello.
I think there is some
Hello.
confusion on your end, sir.
Sound is breaking, sir.
Now I think you are audible. You can try continue, sir.
So after the Niger, this species is able to produce cellulase enzyme.
Hello, excuse me, sir.
Hello.
Sorry, but your sound is breaking down. Do you have any other mobile network or Wi-Fi available?
એમાં કઈ નથી થવાનું.
Network connection is poor. Network connection is poor.
Yes.
Hello. Sir, now it is okay, sir. Now is it okay?
Yes. Yes.
Okay,
Yes. Sorry.
okay.
Okay.
Yes.
So there is problem of network little bit, sir. Now audible, sir?
Very much audible, sir. Please continue.
Yes, audible. You can continue.
Sacrificed biomass was that sugar was estimated sugar methods and that sugar concentration of the algal biomass was evaluated. Simultaneously, the ethanol was estimated by using potassium dichromate methods as well as the specific gravity method was used to find out the amount of alcohol present in the sacrificed biomass. So yeast was used as the fermenting organism and produced ethanol was checked. So I will discuss that later in the portion of result and discussion. So oil which was extracted, that fatty acid extracted from algae oil was transesterified by using a novel bacteria which was isolated at the local place. A genome sequencing was carried out. The lipase producing bacteria was used in the transesterification process. So result in this study, the novel isolated algae was found to be Cholestella vaculotus species. The data of RNA, 18S RNA sequencing was deposited with NCBI and get the accession number, and this accession number was 696162. The phylogenetic construction was carried out by using the joining neighboring methods software tool. So this is the algae which was isolated and identified. Then saccharification of algal biomass. Here the graph showing that how much amount of sugar is generated sugar is near about 40 microgram per ml sugar was generated, and this total sugar and reducing sugar was separately calculated. So ethanol which is generated after the saccharification, that found to be 30 milligram per ml, and when the specific gravity was used, it found to be 3% ethanol. And this is the data which shown this ethanol estimation. Transesterification is carried out, and the result of transesterification is shown in this slide. This is GCMS spectra of algae oil, biodiesel. This peaks indicates that biodiesel is transformed. So this is the key portion. Here, when the set was generated, this bacteria is isolated. This bacteria is able to produce lipase enzyme. When lipase is used as a trans-esterifying agent, so chemical trans-esterification by using alkali in this tube, you can see here large number of other residual material is generated. But when the enzyme is used, that enzyme is crude enzyme which is isolated by this novel species, and here the large amount of glycerol and the biodiesel was transformed. This isolated bacteria was identified as Anorubacillus anurolyticus, and the sequencing deposited at NCBI and get the accession number 69611. So this bacteria is very useful, and this novel algae is able to produce oleic acid in large amount as compared with the reported algal species so far. So with that, I conclude this short session, and I sincerely thanks to Dr. Deshmukh sir who provided me this platform to deliver my speech. Thank you very much, sir.
Thank you very much, sir. I think there is a question in the chat box.
Yeah, sir. Okay, sir. Okay. Standardization of saccharification process using Aspergillus niger to be explained. Okay, sir. So, how this process is standardized? First of all, the algal biomass was allowed to grow with fungal species, and that fungal Aspergillus niger was inoculated into the algal broth at 25 to 30 degrees centigrade was maintained. During that time period, the concentration of sugar was continuously checked. So as the fungal species grow, when it is highly sporulated, I have some slides, but I am not included in this. So when the saccharification is started, the Aspergillus niger grow in whole flask, and then at that temperature, the sugar is related up to 5 days, and then after the fungus species was removed, and the remaining residual material which contains sugar was checked by using a standard sugar estimation method, and it was found that at 25 to 60 degrees centigrade, this fungal species able to produce large amount of that cellulase enzyme, so that cellulose was also estimated before and after the addition of this Aspergillus niger, sir. So that was maintained in the laboratory in standard conditions, sir. Is it okay?
Thank you, sir. Alami sir, do you have any response to that?
So far, no response, sir.
No worries, sir.
Yeah, actually, I somehow connection was poor, so I missed that some part. Actually, a similar procedure we are following for seaweed treatment for obtaining the nutraceuticals, and to deal with the cellulase, we are actually adding bacillus lipase. You know.
Yeah.
So that actually takes care of hydrolyzing the seaweed cellulose, and then subsequently we do the fermentation. So almost the similar procedure what Dr. Chauhan did. That Aspergillus niger treatment first. So that exactly how he did was actually interesting for us. And then subsequently he has used the bacillus lipase for a transesterification. So both the procedure almost on the, what I can say, two-stage fermentation. Even we are also following. Right now we have a similar project on that area. So that's why actually I was just wanted to know. It looks quite promising. Yes. Please go ahead now.
Thank you, sir. Thank you very much. Do we have any other questions in the audience? Please,
सर
unmute.
एक्चुअली आई हैव अ क्वेश्चन
Please,
Yeah,
please
yeah,
proceed.
please.
सर हम बायो अलगी से बायोडीजल फॉर्मेशन करते वक्त हम कौन सी अलगी मतलब यूज कर सकते हैं मोस्टली जो हमें बायोडीजल फॉर्मेशन एक्सेसिव देगी?
तो वहां पे बहुत सारे स्पेसीज है, बट रिपोर्टेड स्पेसीज में से सिंडेमस स्पेसीज, chlorella we can use. So I use this algal species chlorella vaculatus. I found 34% of fatty acid in it. That's why those algae who store the more lipid, they can be a good source for future biodiesel production, sir.
थैंक यू सर.
Thank you, sir.
Yeah, how much was the yield actually? Can you just tell how much was the yield you picked?
Hello.
I wanted to know how much is the biodiesel or ethanol yield you get in a percent or dry weight basis.
Yeah, sir. So when I extracted the oil, just I use just 5 kg of dry algal biomass. From
Okay.
that, from that I used to extract just 300 ml of oil, sir. And that, yes, and out of that, for experimental purpose, I use 5 ml of this algal oil. And for transesterification reaction, I just use 5 ml sample, sir. And out of this 5 ml sample, I just went for transesterification reaction. And after that reaction, that quantity I was not measured. Just the residual sample I sent to Mumbai, IIT Mumbai for his GCSMS analysis. On that basis, only the transesterified product which contain this biodiesel failed. That was I obtained, sir. But actually, how much diesel actually working diesel, that I don't check, sir.
Yeah, maybe next step now you are in a job, so you can actually take up this work subsequently. And then in ICT, you must be knowing some of this group are working on bioenergy.
Thank you very much, sir.
They have designed some of these fermenters in a laboratory only, and then they use this seawater for the feeding, for growing the microalgae. And they have actually the process standardized. I have forgotten exactly the professor name in ICT Mumbai, but they are actually a very good customized system for biodiesel production, basically.
Thank you for this information, sir.
Yes.
Thank you, sir. Do we have any more question in the audience? All right, sir. It was a very nice and short and crisp presentation. Thank you very much.
Thank you very much.
Thank you. I would like to speak out one fact that under this PhD webinar series, Microbiology Society of India is giving mementos and certificate to each speaker. So please get in touch if you have recently completed your PhD. We will let you speak and present to everybody for the betterment of the subject. Thank you, everybody. Thank you, Deshmukh sir. Thank you, all the attendees, and especially Dhanpal Chauhan sir for your esteemed presence.
Thank you very much, sir.
हेलो सॉरी सर फॉर द डिस्टर्बिंग सर. एक्चुअली मुझे धनपाल सर से एक रिक्वेस्ट करनी थी सर. आप आपकी जो पीपीटी है वो शेयर कर सकते हो क्या आप मेरे साथ या अपने ग्रुप पे माइक्रोबायोलॉजी में?
बिल्कुल करूंगा सर. मैं थोड़ा उसको रिवाइज करूंगा, आपको बहुत अच्छे से दूंगा, वन स्टेप बाय स्टेप. सो मुझे बोला गया था कि विद इन 30 मिनट यू शुड वाइंड अप योर प्रेजेंटेशन. दैट्स व्हाई आई ट्राई टू मिनिमाइज इट इन शॉर्ट.
ओके सर, थैंक यू. एक्चुअली सर मेरा वो प्रोजेक्ट उसी पे चल रहा था, ऐसा मुझे वो हेल्प होगी उससे. थैंक यू सर.
Thank you. So you please note down sir's email address. It is in the chat box. So you can, discuss with him.
Yes, sir.
Okay. Okay. Thank you, everybody.
Yeah, thank you very much.
Bilkul, sir.
Thank you. See you on next Sunday.
Yes, yes. And thank you, Dr. Chauhan, for a nice presentation.